And we're very pleased to have today with us in our Bar-Ilan University Vision Science Seminar, Professor Ran Hassin from the Hebrew University. Professor Hassin did his PhD at Tel Aviv University and then continued to a postdoc at NYU. After then, he joined the Hebrew University as faculty, and today Professor Hassin is the head of the lab Consciousness at the psychology department at the Hebrew University. He's also a member of the Center for the Study of Rationality at the Hebrew University and a minor association. He is also an adjunct senior research scientist at the Department of Psychology at Columbia. He's the editor of Oxford University Press's Social Cognition and Social Neuroscience book series. He published dozens of peer-reviewed papers in top leading journals and also 2 books, and he has an H index of 41 according to Google Scholar. He's interested in and his research focuses on understanding the capabilities of unconscious processing and in using this knowledge to gain insights into the functions of consciousness. His research examines many aspects of unconscious processing, of working memory, executive functions, goal pursuit and motivation, goal conflict, self-control, and even nationalism. In addition, he also examines higher cognitive functions and how bottom-up, such as from different modalities or inputs, or top-down processing affects them. These are mainly investigated via behavioral measures, but also they include physiological and patient data, as well as brain imaging. So without further ado, I'd like to invite you, Ran, to our seminar today to hear about your exciting research, and thanks so much for joining us.
Thanks, Joan, for this introduction. It becomes less and less identifiable the more I age, but yeah. So I'm going to look here. This is my other screen with a PowerPoint, and you can stop me at every point to ask questions. And if I want to take them, then I'll just delay them to the discussion. Definitely, if you have clarification questions, but also non-clarification questions. So I'm going to talk about something that we discovered that we call non-conscious prioritization speed, and it's I hope to persuade you that it's both robust and mysterious. And what I want to do here today is actually ask for your help. So by the end of the talk, I will have shown you, I don't know, 13 or 14 studies with hundreds of subjects with something we know very little about. We know nothing about the origin of this thing that we discovered. We know a little bit about its downstream consequences. And I think by the data that we have is not data of cognitive psychologists like me. And when we get when we get correlations between measures of 0.9 and 0.8, this is not something we know what to deal with. Give us our regular 0.3, 0.4, we're fine. So I suspect that some of the things we do are really in your field, in vision sciences. So if you have any insight as to what causes the thing I will tell you about and where to look for it, I'll be more than excited to hear. The plan for today is the following. I'll give 2 mini introductions. They're not strictly necessary for the presentation today, but it'll give you the broader framework within which we work. And how we got to ask the questions that I'll talk about today. This will take around 10 to 15 minutes, and then we'll get to the main part where I'll share with you the studies that we've been conducting in recent years about the speed of prioritization. So mini background 1 is consciousness as non-conscious processes. When I give this talk to real-life audiences, I pick someone from the audience and then I pick at someone, but I won't do it here today. I basically ask people, how much will I have to pay them in order to, okay? One, the first thing is cut their hair. I have little experience from my kids, but not much. Then I ask to cut the little finger, cut an ear, cut 2 legs, and give up on consciousness. And the main idea in this thing is that people, the numbers that people ask. We also ran an experiment on MTurk with the same question. So then the sums that people ask for are really different, but they're kind of okay all the way up to the 2 legs thingy. But for consciousness, no one is willing to buy it. People put the price of consciousness at the price of death. Okay. even though I will, promise you that no one will know that you're actually the same you, but without consciousness. You'll be the perfect philosophical zombie. You'll walk around, you'll tend to your kids, you'll have a love life. You won't be in love, but you'll have a love life, whatever. People are not willing to take it. Those who are willing to take death are willing to take loss of consciousness. Those who are not willing to take death will not take loss of consciousness. And the bottom line here is that we really love our consciousness. This is the only thing that we have about us in terms of internal feelings. These are our feelings, our thoughts, our inclinations, our insights, our love, our hate, whatever. This is what we have. Without this, we have nothing, or so do people think. We will not take decisions, I would say serious decisions without stopping to consciously think. And we find it really hard to identify with ourselves without consciousness. And in recent, I would say, 3 decades, the research about consciousness has flourished, but there are a few little open questions, and I want to talk a little bit about them. One of them is who has consciousness in terms of the tree of life. Okay, do amoeba have consciousness? Do monkeys have consciousness? Pigs, dogs, ants, and what have you. This is not only a theoretically important question, it's also morally important, right? Because it will be, if we discover by any chance that, 256 cells of an embryo can actually fear death, we'll think about issues differently than if we know that there's nothing like that in there. If we'll think that the cow, who is about to be butchered, thinks to herself, "Oh, they're just not," and really suffers, then we'll be more easily or less easily be willing to eat meat, and so on and so forth. In recent years, there's a lot. Can you see my cursor? So in recent years, there's a lot of talk about AI consciousness. Does AI have consciousness? Will AI have consciousness? Again, it has moral and frightening consequences. I think AI might have consciousness, but it won't have human consciousness, but I won't be talking about this today. If you want to learn anything about the evolution of who has consciousness, this is a great book by Simona Ginsburg and Eva Jablonka. They have done an amazing work in asking the questions and surveying the literature. I do not necessarily agree with what they say, but you'll definitely get to think a lot while reading their book. And there's a shorter version published a couple of years ago, I think in Frontiers. Another question is how is consciousness implemented in the brain? And here, I think dozens, if not hundreds of millions of dollars have been used in the last 30 years to try to figure out what are the neural correlates of consciousness, what is it that consciousness comes with in the brain, and what in the brain causes consciousness. I'm not from the field. I'm a cognitive psychologist. I will only say that I think that we have made progress, but not a ton of progress, in my view. The more interesting question for people like me is, what does consciousness do? And throughout the years, there have been many, many proposals about what is consciousness necessary for? What is this thing that we cannot have if we don't have consciousness? And, arguments went from language to communication to theory of mind to mental control. The last two options here are the prevailing theories of consciousness today. This is broadcasting of information, or fame in the brain, as Dan Dennett put it. The idea is that what consciousness gives you is fame in the brain. As long as you're unconscious, you can be there in the brain, you can do your stuff, but no one knows you, no one hears about you, it doesn't get anywhere, or it doesn't get far. It gets some places, but not far. If you're now in consciousness, you're fame in the brain. You can do whatever you want. You can affect plans, and you can affect thoughts, and you can affect decisions, and what have you. The other view is by Tononi and Koch, information integration theory. It has to do with the fact that consciousness is, they argue, integration of information. And to each one of these options, there's also evidence to show that it doesn't have to be the case, that you can have language without consciousness, that you can have theory of mind without consciousness, that you can broadcast information in the brain without consciousness. And so the data goes both ways. Around a decade ago, I offered this, a view that I called yes, it can. The view basically says that every fundamental basic level cognitive function can occur non-consciously. It doesn't mean that it happens in the same way. It doesn't mean that it happens to the same extent. It doesn't mean that it happens in the same circumstances. It's just a point about necessity. You don't need, strictly need consciousness to any of the fundamental basic level cognitive functions. You won't be surprised to learn that not many people agree with me. um, but I still think, I still think it's true. Anyway, so that's about consciousness as non-conscious processes. Then we moved on to offer an alternative of our own as to the interaction between conscious and unconscious processes. And here you see Asael Sklar, who's currently an assistant professor at Reichman University. And this is Rasha Kardosh. He's currently a postdoc at NYU and will become a member of our faculty next year. So the minimalist hypothesis has two tenets. One of them is that cognitive functions always occur non-consciously. And the other is that conscious events tend to extend in time. Now, the idea that conscious events tend to extend in time, is easy. Everybody agrees, all the theories agrees, all dual system approaches agree, or theories of consciousness agree. So that's not a thing. We all know that it takes time for material to become conscious, and that once things are conscious, they might stay there for a while. Okay, so that's not a thing. The idea that cognitive functions always occur non-consciously and can also only occur non-consciously is more open. And what I'll try to do here today is give you an intuition as to why this has to be the case. I have to say that 3 years after we published this thing, we discovered that many people have discovered this before us, some millennia before us, but at the time we didn't know that. Okay, so here's a easy math problem, 12 times 13. Try to do it in your head. Think about how to go about it. And I want to talk about this example for a second. So what we offered in the paper is a method we call microanalysis. And in microanalysis, what we do is we zoom into a cognitive process and then we move slowly. So we zoom in, we see things up close, and we move slowly so that we can see what happens, okay? Now up here, you see conscious contents. So these are things that you consciously experience. And down here are the hard labor of the non-conscious or the unconscious or whatever you want to call this thing. And now we'll do the math with those, okay? So I asked you questions, how much is 12 times 13? You might have said to yourself something like, okay, let's do 12 times 10 and then 12 times 3. Where did this thought come from? You have no idea. You didn't bring it to mind. It came to mind, okay? And then something happened here. And then you said, okay, it's 120 and 36. What happened between here and here? You don't know. It's inaccessible to you in terms of what happened there. Maybe you retrieved it from memory. Maybe you actually computed it in some ways. Who knows? But what happened between these two things is not transparent to you. And then something else happened, and they say, oh, it's 156. Okay? So if we zoom in on the process and we move slowly, we discover that we have conscious contents here, but that the move between the conscious contents is done by non-conscious processes, not by consciousness. Okay? Consciousness did not move you from here to here. The non-conscious processes did. Let's take a more elaborate example. So suppose the first thought that came to your mind was I can do it this way or that way. Again, how did this thought come to your mind? You don't know, but then something happened and you chose this way and not the other one. Why did you choose this way? Who knows? The thought just happens to you. Okay, I'll do this way. It might be easier. How did the thought it might be easier came to mind? Again, it came to mind, you didn't bring it to mind, and the rest goes on to the exact same thing. Now, let's take a little less boring example. So let's think about decision-making Hollywood style. Okay, so your girlfriend, your boyfriend suddenly hears the following words: "Will you marry me?" Okay, here's the stimulus: "Will you marry me?" One thing that can happen is yes, I will. And then you see cake and everything is fine and love will prevail forever and democracy in Israel and whatnot. Okay, now again, this is the stimulus. You didn't think about yes. You didn't think, shall I say yes? Should I say yes with three question marks? Shall I shout yes? No. Just happened. You said yes. Could have gone a different way. Could have been, will you marry me? Let's think about pros and cons. Now, A, probably your boyfriend, girlfriend is not going to like that, but never mind that. Where did the th thought about pros and cons came to? It came to you. You didn't bring it. Then you said, okay, I'll do yes. And you can, and we can do more of that. We can do, will you marry me? Pros and cons, and what does X, whatever a pro or con mean, and so on and so forth. And then maybe, and then maybe not. The point I think is clear by now. Thoughts, motivations, feelings, decisions, perceptions, they come to mind. We don't bring them to mind. So the thing that we call thinking, okay, is actually conscious contents that are manufactured by non-conscious processes that move us from one thought to another. Now, this doesn't have to be verbal, okay? It can be visual, it can be auditory, it can be whatever you have. The move from one conscious content to another conscious content is never done by conscious processes, okay? So in a sense, the idea of conscious processes in itself um, doesn't stand because the processes are not conscious. The contents are, but the processes that move us in the process are not. Okay, so this is the background, as I said, to the talk that I want to give. And what the minimal hypothesis gives you is A, it gives you the current views of consciousness in it already. Okay, because consciousness takes time, and because the things that happen to you, you integrate information, and you can become famous in the brain. What the model highlights is the determination, how we determine how the mind determines what becomes conscious and what's not, and the interactions between conscious and unconscious parts of our thinking. So this is where I'm going to head today. Any questions until here?
Yeah. I mean, actually, I've got a few questions, but I'll leave them to the end because they're, yeah, they're philosophical. So yeah.
Okay, sababa. So chapter 3, what I want to consult you with are the processes that prioritize information for consciousness. So the basic idea is that there are all sorts of things going on in our brains at any given point in time. Only a small fraction of them become conscious. Some of it might be randomly chosen by noise, but most of what becomes conscious doesn't seem to be determined by a random procedure, right? We don't think thoughts like, I wish, I don't know, I wish cucumbers were orange and round. Doesn't happen to us. That's not a thought we think. What to buy for dinner tonight? That's a that's a thought we have. Okay, so it doesn't seem to be random, and we worked a little bit on motivational relevance, on how our motivations determine what comes to mind, and we worked on facial dimensions. What is it that make faces more salient, that become more conscious easily? And then while we were doing this thing, these two, this guy you already met is Asael Sklar, who's currently in Reichman, and this is Ariel Goldstein. He's currently a professor at the Hebrew University, and he's moving next year to England. And they came to me with a cute idea, and they say the following thing. We have an intuition that there are people who see more easily than other people, that they're easy seers and more difficult seers. And the example they gave, and the example that I use since then, is to ask people who've been in long-term relationships if they, are going to meet someone at the corner of a street next week. Okay, so this is 110 in Broadway. You're about to see a friend of yours that may be waiting for you or not. You said you'll meet her at 1. Will you or your spouse see her first, see your friend first? Will you or your spouse or your parent or your boyfriend see, a car in the street that it approaches you in a dangerous way first? Will it be you or her? And people in long-term relationships know exactly who sees, who's the seer and who's the non-seer. I'm the non-seer. I'm just coming clean. I see nothing, never saw anything. My wife does, my daughter does, my son doesn't, which is why riding a bike is really dangerous for him. So they had this intuition that this thing existed. You talk to people, they know whether they have it or not. And we decided to start going for it and see what happens. And the general paradigm I'm going to use it throughout the experiments is simple, okay? We're going to expose participants to subliminal stimuli. The stimuli become stronger with time, so at some point in time, you can see them or parts of them, okay? And what participants have to do is to indicate something about the stimulus. So in some experiments, we ask them whether the stimulus is on the right-hand side or the left-hand side, up or down, corners of the screen, something. And then what we measure is how long does it take them to indicate that they see something, okay? That's our dependent measure throughout the experiments. You're in an experiment, and that's what you have to do. We use two techniques to present subliminal stimuli that then become stronger. One of them is called continuous flash suppression by Tsuchiya and Koch in 2005. Basically, you separate the input into the eyes. This is a stereoscope, but you can do it today with 3D glasses. You separate the input into the eye, and in one channel, you put very noisy things that change fast, colorful, changing fast, blah, blah, blah. And while you do that, you can put things in the other eye, and you won't experience them at first. So your experience will be of the changing colors and rectangles until at some point you'll see the other eye. Now, unlike subliminal, priming that, you can prime things, let's say up to 30 milliseconds, 60 maybe, but not more than that. If you prime flags, you can go up, you can go higher than 15 milliseconds, okay, depending on what you prime. Here in CFS, you can show stimuli for seconds, sometimes 10, 15 seconds, okay, and subjects don't see them. So you have one eye in front of which there's a stimulus, okay? The stimulus Bar-Ilan rocks just stands there in front of my left eye for 5 seconds, okay? While there's noise in my right eye, and I don't see it. And then at some point, we ask subjects to say, whether the words, in this case, appeared above or below fixation point. We're also going to use what we call repeated mask suppression, which is something that we developed in 2020. It's basically pre-post masking going forever, okay? So you have a mask, stimulus, a mask, stimulus, a mask, stimulus, and so on and so forth. Turns out that if you do this, you get the exact same conscious experience. In the beginning, subjects just see the noise, just see the masks. And then at some point, they begin to see what's in between the masks, okay? So these two techniques allow us to present stuff for seconds, and as you see, sometimes 10, 15 seconds without subjects consciously experiencing them. Okay, so that I said already. Okay, I'm diving into the data. Before I dive into the data, any questions about the paradigms? No, it's about. So first experiment, 14 participants, 192 trials. The stimuli were sad, happy, neutral, grayscale faces from the Ekman set. So this is the mask. The mask is here, black and white. And these are the faces taken from Ekman. Subjects had to say whether they appeared on which corner of the screen the stimuli appeared. And we're going to see this kind of slide a lot today. So I'll walk you through it. So here you have, let's say, the correlation between what happens when we mask the left eye or the right eye. So we can mask each eye, right? And you can see that there's a strong correlation between eyes, okay? The dependent measure is, of course, how long does it take stimuli to break into consciousness, to become conscious. And what you can see here is very, very strong correlations between the eyes. And what you can see here that you can correlate how long does it take you to see happy faces and sad faces, happy and neutral, sad and neutral, and all the correlations between these stimuli are extremely high. Okay, so if you're in a session, if you're in our experiments and you're asked to tell us, when as fast as you can, where does the face appear? Seems like it happens to all stimuli that we presented to you in this experiment. 14 subjects is not something to be impressed of when you look at correlations, but you'll see that we'll have more data, and you'll see that when it doesn't work, it doesn't work. Is it really a trait? Is it really something about us, or is it something that about the here and now, something that changes with mindsets and so on and so forth? We had 2 such blocks with 15 minutes apart, okay? The stimuli could be upright or inverted. Again, you can see very strong correlation between first block and second block. So again, this is 10 to 15 minutes apart, and the correlation is 0.02. Now I can Fast forward to 2025, we just analyzed data from another experiment that we ran a year ago, and we have now T1, T2 with 35 hours apart. Okay, so we measure subjects, then we measure them again a day or 2 days later, and again you get the same kind of correlation. Okay, so it seems like a very stable measure for people. If we get 0.75 after 35 hours, it's a very stable measure. Okay, it's more stable, I think, than Stroop, for example. In experiment 3 to 7, we showed subjects all sorts of things. We'll show them moving arrows. The arrows could point one way or point the other way, and they can be congruent, so they point and move in the same direction, or they can be incongruent, they point and move in the other direction. We showed them videos with people. So again, the videos are masked, right? No videos. They don't see them, but we showed them videos either with people or without people, and we showed them verbal expression that I'll talk to you about in a second, okay? Here are the moving arrows. Moving right, moving left, 0.7 correlation between the two, congruent and incongruent, 0.84, each point is a subject, okay? The videos, talking people versus other scenes, you see the correlation is a little weaker, it's 0.62, but again, very, very significant. The expression is nice. Expression is something we reanalyzed data we published a few years ago. And we had an experiment in which we showed subjects verbal expressions that are composed of more than one word. So we showed them verbal expressions like babies in oven, a baby in an oven, okay? Babies are good and ovens are good, but babies in ovens are not good, okay? So when I say a negative expression, I don't mean that the words are negative. I mean the expression itself is negative, okay? So babies in the oven, not good. Again, concentration, good. Camp, good. Concentration camps are not good, and so on and so forth. Okay, so we look at the expression, at the affect of the expression. Again, you can see very strong correlation between negative and positive expressions, in when they become conscious. Experiment 8, we move to RMS that I told you about, repeated mask suppression. We have different stimuli with different opacities of the screen. You can see the opacities, and you can see that in all levels, there's strong correlation within the CFS block. We also did correlation between the RMS, the one that I showed you here, and CFS, the one that separates the eyes. Phenomenologically, they feel the same, but masking is completely different, right? Masking in CFS is from one eye to the other. Masking in RMS is temporal. It's from one moment to the other. So we get decent correlations in different blocks, something that ranges between 0.5 and 0.63, which is what you'd expect from something that measures the same thing, but in really different ways. So far, I hope you're convinced that there is such a thing as non-conscious speed, and it's there for various visual stimuli, moving objects, positive and negative verbal expression is stable over time. But okay, so there is a thing. Should we care about it? So let's begin by trying to figure out what this thing is. Okay, one option is that it's just general speed. Some people are fast, some people are slow. Fast people see fast, slow people see slow. Okay, still an interesting trait in terms of consciousness. Still, people become conscious faster than others, but it's just part of this general trait of being fast or slow. So we have 22 participants, they do CFS, and then they do the same kind of thing, but without the masking. So they see just this part, they see the faces and the houses, and they have to say left to right, exactly like in CFS, but without masking. If it's about being fast or being slow, then people should be fast or slow on both tasks. You can see that within CFS, we get the regular correlations between here, it's right eye and left eye, but the same is true for blocks and houses and faces. By now, I can tell you that this guy, there's something wrong with it. It's something, you never see people here. So this is a guy, or I don't know if it's a man or a woman, who when she closes her right eye, she doesn't see. She sees very, very slowly. But when she closes her left eye, she sees very fast. So something is wrong. If you take her out, we didn't because it wasn't registered, then the correlation becomes a regular one.
Are you testing for binocular the vision? I mean, is your outlier subject just an amblyop or something like that?
It might be. In the RMS experiments, it can't be because we mask in time, but in CFS, it might be the case. Um, Here's the correlation between CFS and conscious speed. There's basically nothing, okay? There's no correlation between how fast you are on the conscious task and how fast you are on the non-conscious task. Is it just decision threshold? Some of us need more information in order to reach a decision. Some of us need less information in order to reach a decision. If I need more information, I'll be slower on the RMS task. If I need less information, I'll be faster. So we did the exact same thing. This is the CFS block that you know. And now instead of putting the stimulus just in one eye, we put the stimulus in both eyes. Okay. So you have mask for one eye, but the stimulus for both eyes, so it's visible from the first moment, okay? And if it's just about how long does it take you to accrue pixels that are above the screen, above the center, then it should be the same thing. You should see strong correlations. If it's something else, then you should not see strong correlations. Again, within CFS, we see strong correlations between right eye and left eye, between block 1 and block 2. CFS and conscious RT are completely uncorrelated. So it's not that. So it's not general speed and it's not accumulation of information. Is it attention, we thought? And as you can see, we're trying to figure out what is this, where does this thing come from? And we fail and we won't succeed, I can tell you in advance. We won't succeed. We don't know where this thing comes from. So we did the CFS and we gave subject the Posner's ant paradigm. I'll say a word about it in a second, but I'm guessing you guys know it much better than I am. And we also gave them a visual acuity test in the lab just to make sure that when they say that they see 20/20, they actually see 20/20, and it's not about differences in eyesight. The ant gives us three indices of attention: alerting, orienting, and executive. Um, Here's the CFS correlations. Again, the regular strong correlations. Nothing with the ant. It's not alerting, not orienting, not executive attention, and it's not visual acuity. It's not that subjects simply don't see well. So far, we completely failed. I can tell you that we looked at iconic memory too. It's not here in the presentation. Again, didn't yield anything. And we looked at short-term memory. Again, didn't yield anything. So as far as causes of this thing, this trait go, we're currently clueless. It's there, but we have no idea where it comes from. Yeah.
Ran, do you want suggest or ideas now or at the end of the talk?
At the end, I'll be
Okay.
excited to hear
Yeah,
ideas.
okay.
So should we care? Is it an interesting or not interesting? It might be something, it might be an individual trait that for psychologists is not interesting. We don't know. Now, I say in advance, all we have are correlations. We don't have causality here, but I'll show you correlations of what we think are likely to be consequences of having short or long, taking you short or long to become conscious of stimuli, non-conscious processing speed. So here's one study that was published earlier this year. We had subjects do a change blindness paradigm. So, here's the picture and here's the same picture with a slight change, and they flicker. You see first one, second one, first one, second one. You have to press a button whenever you see the change. And then because it was run online, we ask you to tell us where in the screen was the change. Okay, so if you look at this, if you look at the place of the change, we'll say you saw it. If you missed the change, we'll say you didn't see it. Subjects did dozens, I think around 20 or more change blindness, and they did the CFS. If you look at the 20 fastest subjects in NPS and 20 slowest subjects in NPS here, you can see that their accuracy levels are different, okay? Subjects who see fast see more of the changes than subjects who see slow, okay? presumably because subjects who see fast see more. They sample the environment more frequently than subjects who see slow, right? If it takes me 2 seconds and it takes, I don't know, a Yafa 100 milliseconds, she'll see much more in the environment than I will see, okay? A cute way to look at the same kind of data is to have accuracy per time point. So on the x-axis, you have time point in a trial. Now, this is all subjects, all trials, okay? And you have the 20% who are slower, the 20% who are faster. And you can see two things here. One is that in the beginning, in the easy change detection tasks, the questions, the one that we solve in 5, 4, 6, 10 seconds, there's no difference between the two. They solve it to the same extent. It's the more difficult questions that yield the difference. So then we need more time, and those who need time and don't have it are less accurate. Now this dark line here just represents when does the difference become significant, and it's around 15 seconds in a trial. Okay. Now this analysis was not pre-registered. We discovered it post hoc, so we ran a replication with pre-registration and everything and a few added thingies, and we get the exact same result. Okay. Fast subjects are more accurate in detecting changes as long as we limit you for 60 seconds. Maybe if we stay there for much longer, you'll see it in the end. But at 60 seconds, subjects who see fast see more changes. They sample the environment more often. The last experiment that I have in this set has to do with memory. Again, the basic idea here is that subjects who are fast sample the environment more often, so they see more. They'll see more of the changes. They'll see more of the environment, okay? So we let subjects play Minecraft. Those of you who have kids know Minecraft. Subjects go here and they go about the city and they have to kill bad guys and walk around and get to the end. And on their way, on some of the signs, there are stimuli. You can see your horses. In here, I don't know what this thing is, but it's something, maybe a cape. Some of the thingies are empty.
Shark.
Okay?
Shark.
Shark. Yeah, it's a shark. You're right. You're right. It's a shark. Not all were dangerous animals, by the way. And so they play this game, and they do CFS later. And then we have surprise memory test for them in the end. Okay? Again, assuming that subjects who see more might see more of the environment and might remember more of the environment. And this is exactly what we get. So on the x-axis, you have how fast you are in NPS. On the y-axis, you have accuracy and memory. And there are two things to see here. One, the two are mildly correlated. And B, there's a ton of noise. Okay? They're mildly correlated. It's not a strong correlation. It's not that surprising given that we're looking at memory for things that happen during the walk, and they have 5 walks and it takes time, and memory has its own things, as we all know. So it's not a very impressive correlation, but it is a correlation nonetheless that supports the idea that subjects who see fast in our task sample the environment more and to some extent remember it more. So what I tried to persuade is that we found a robust trait. We really know nothing about where it comes from, and I don't think it can come from high-level cognition. And we're beginning to understand some of the downstream consequences if we're right, and if what we measure in the lab really, somehow measures how we see in real life and not in weird tasks that we invent, then sampling the environment more means a lot, okay? If I do it auditorily, it means that I will miss less words in a conversation. If I do it visually, it means that I'll miss less emotional expressions in faces when I'm interacting. I'll miss less of what happens in the street. I'll miss less cues. I'll make more car accidents and so on and so forth. We don't know yet that it's the case, but this is where we're going. So thank you very much for your attention, and I'll be excited to hear questions and especially suggestions. Where should we look? What are we missing?